Hello AP friends, hope you are doing well. This video is going to go over the solutions to this worksheet for the fundamental theorem of calculus, which is ever so important, so I'm glad we're reviewing it today after our very long break. So hopefully you've done all the problems successfully, so this video will just go over the solutions, so make sure you finish the whole thing first before you go over this video. So we reviewed a little bit in the first 2 pages here, which gives an explanation of just part 1, which talks about when you take the derivative of an integral. And as you see here, when you take the derivative of an integral, the derivative kills the integral, and you should just be left with the inner function, with basically just that x plugged right in. But always double check before you take the derivative using FTC. Do you have a number on the bottom limit of your integral? And do you have an x or some kind of function on the top? But as you see in the second example, the function on the top is not just x, it's an actual function. So when we take the derivative, it will destroy the integral. You'll plug the function in for t, but you also have to include, by chain rule, the derivative of the function. So this is why the answer to the example here is this. Then you got a chance to go through example 1, which is a pretty straightforward one. When you take the derivative of x, let's double check first of all, before you use FTC, is there a number on the bottom? Yes. Is there an x on the top? Yes. So we are good to go. And it is just an x, so we don't have to use chain rule here. All right, the derivative should destroy the integral, and the x should just be plugged into the t. Integral is gone, and you're left with 1 over 1 plus x cubed. Notice that we don't take the derivative of the inside, we're just taking the derivative of the integral, which eliminates it. Answer for example 1. For example 2, very similar. You're taking the derivative of an integral. Let's double check. Number on the bottom, check. X or function on top, check. But you can see it is a function, so we're going to have to include chain rule here. And the chain of this is going to be 2x. All right, first thing to do, when we take the derivative, it's going to destroy the integral and plug the function in for t. So I get the square root of x squared plus 1. But again, because of chain rule, we're going to include 2x with it. And there's your final answer. That's using FTC. All right. So the best thing to do is to go over these solutions by this. I'm going to give the answer first. And if you got it right, just skip forward and go to the answer for the next one. But if you ever get an answer wrong, I'll go over the solution after that. So you can pause, you can zip forward if you ever need to. All right. Here we go, folks. Number 1. The answer for number 1 is C. Did you get it? If you did, zip on forward to number 2. Otherwise, here's how we do number 1. All right, number 1 is FTC. You want to take the derivative of an integral, which is going to destroy it. But let's double check first of all. Is there a number on the bottom? Yes. Is there an x or a function on top? Yes. But do you see that it's x squared? So we're going to need chain rule here. All right, so what we're going to do is when you take the derivative, it's going to destroy the integral, and the x squared should be plugged in for the t, and then we're going to include chain with it. I would get the square root of 3 plus, instead of t squared, the function gets plugged in for t, and I get x squared squared. And because it's chain, we're going to multiply by the derivative of x squared, which is 2x. Let me put the 2x out in the front. I get 2x square root of 3 plus, well, x squared squared should just be x to the 4th, which is why we get C. Number 2. The answer for number 2 should be also C. This one's an interesting one. Let's check it out. For number 2, they give you this range here in the front, which is not super important right now, so we can skip over that. But again, you're given a function which is an integral, and it's asking for the derivative. So you're thinking FTC, you want to destroy the integral. Let's double check. Number on the bottom? Yep. X or function on top? Yep. But again, I can see I'm going to probably have to use chain here. All right, well, when I take the derivative, it should get plugged in for the t. So here we go. The derivative should be integral destroyed 1 over the square root of 1 minus, not t anymore, but the function of sine x squared. And by chain, let's multiply by the derivative of sine, which is cosine of x. Okay, if we keep just simplifying this, I should have a cosine on top. On the bottom, I should have the square root of 1 minus sine squared of x. I remember that bottom. That bottom is a Pythagorean identity. For those of you from pre-calc regular, we called it the Bible. So 1 minus sine squared is the same thing as cosine squared. Does that pop up much on the AP? Not really, but kind of neat to see it here. All right, so we're going to simplify this to cosine on top over, well, the square root of cos squared is just cos. And cosine x over cosine x is just 1. Number 3. The answer for number 3, you should have gotten B. If you got it right, fast forward. If not, let's go over it. Number 3, here's your function, and you want to find the derivative, and then we're going to plug in 4. So let's find the derivative first, and then we'll plug in 4 into our answer. All right, the derivative of the integral should kill it, but let's do that double check again. FTC, number on the bottom, check. X or function on top, check, but it's not a normal x, so we'll need chain rule. All right, when we take the derivative, it's going to kill it. I'm going to plug in for t, and here we go. I should get f prime of x without the 4, not yet, should be the cos of, not t squared, but the square root of x squared. Let me make a little separation here. Get out of there. And by multiplying by the chain rule, the square root of root x, if you change it to x to the 1/2 power, should be 1/2 x to the negative 1/2. Okay, well, I could do a little bit of simplifying here because I know the square root of x squared is just x. So I'm going to move over here for a second. Come here, folks. So this should be equal to, how about the cosine of x times 1 over 2 times x to the 1/2. Just simplifying the x to the negative 1/2 power. Okay, now, why don't we take this answer and we're going to substitute in 4. And we get the cosine of, well, x is 4. I get the cosine of 4, which looks strange, but we did it right. And you start to notice that the answers have some cos of 4s in it, so that looks pretty good. Times 1 over 2 times 4 to the 1/2. 4 to the 1/2 is the same thing as just 2, square root of 4. So I get cosine of 4 on top over 2 times 4 to the 1/2 is 2. So I get cos of 4 over 4. There you go. Number 4. If you got this one right, number 4 should be C. And just looking at the answers, do you notice all these decimals? So definitely it's going to be a calculator problem. So hopefully you noticed that and you were able to use your graphing calculator. All right, let's check this problem out. Here's your function. Here's your range, or domain particularly. So I know that when I use graphing calculator, I should put that as my window to make sure I have a really accurate view of this graph, whatever I'm doing. I want to find out if this is f of x, where is f increasing? You remember from way back when, section 2.8, f is increasing when f prime is positive. So we need to find f prime, which means I need to find the derivative of this integral, FTC all over again. Let's do the double check. Number on the bottom, x on top, and only an x, finally. So no chain rule here. Oh, God bless. Here we go. Let's find the derivative. F prime of x should be, integral is destroyed, x gets plugged in, I get cosine of x squared plus 2. No chain. So the question is really saying, where is this greater than 0? Where is this positive? So here we go to the graphing calculator. Graph it. Use our window here. And when you do graph it, you get a really interesting shape. But you do notice that it crosses in 2 spots. Some kind of this shape, as I remember. As that's where it is above the x-axis, that's where it is positive. So we basically need to use the 0 feature to find out what those values are. So using your calculator features, use the second trace or second calc, find that 0, And that gives you a good clue. If you get 1.647, that's going to be either this one or this one. Although visually, using a little bit of logical thinking, you can see that's going to be after 1.647, so it's probably C. But just for good practice, let's find this one. And you get about 2.419. So therefore, where is the derivative positive? Where is f increasing? At C, between 1.647 and 2.419.